is my temperature sensor ISP. As you can see, the printed circuit board version can display the temperature in degrees Celsius and degrees Fahrenheit, and so does my breadboard. The PCB includes the same components, except it has additional components such as female headers, the 4 screws, the 4 brass inserts, the PCB, and the case as well. The case has the 25% infill, which makes it light but also gives it some strength, and it's made of PLA, which is polylactic acid, which is user-friendly and thermoplastic and has strength and stiffness. The breadboard circuit uses the same components. It includes the TMP36, the Arduino Nano, the 16x2 LCD, and the 10K ohm potentiometer. The most important part of this temperature sensor project is the TMP36, which is an analog temperature sensor. It is connected to the 5-volt pin of the Arduino Nano and the ground pin, and the middle pin of the TMP36 is connected to the analog pin 7. It is important to note that the TMP36 has a sensitivity of 10 millivolts per degree Celsius. And we can see that in the code A7, analog pin 7, is defined as the TMP output. It'll be used to change the analog value of the TMP36 into degrees Celsius and Fahrenheit. These are the two formulas necessary to convert the analog value of the TMP36 into voltage, which changes it into temperature. The first line is float voltage is equal to reading times 5/1023. So we get the raw analog value and we send that for analog to digital conversion to get a voltage value. When we get that voltage, we subtract 0.5 for 0-point calibration, because when this TMP36 sends out 500 millivolts or 0.5 volts, that can be calculated to get 0 degrees Celsius just to calibrate the TMP36. And the actual temperature is 4 degrees less than the temperature that we get from using the calculation to get voltage and temperature. And we subtract that offset, which is about 3 to 4 degrees, and that gives us the degrees Celsius. To present Fahrenheit as well, we take that actual temperature, the accurate reading, and we multiply it by 9/5 and add 32. There is the use of parallel interface instead of the I2C in this circuit, and as you can see in the code, there are a few pins that need to be stated as constant variables. So those pins include the register select, the enable pin, digital pin 4, digital pin 5, digital pin 6, and digital pin 7. And we need to initialize the LCD display by stating those constant variables and creating an instant. The VO pin of the 16x2 LCD is connected to the middle pin of the potentiometer because that allows us to adjust the brightness of the text that is displayed on the LCD. The TMP36 analog temperature sensor has shown itself to be a reliable and highly efficient solid-state device. Although it's slightly less accurate than the traditional mercury thermometers, it is still able to display temperature readings in Celsius and Fahrenheit in real time with just the use of 2 or 3 formulas.